Okay, so this video is going to look at adaptations to anaerobic training programs. So this chapter goes over anaerobic training programs, and the next one will go over aerobic training programs. So we're going to see how the body kind of adapts to each one of these different types of exercises and what what anaerobic and aerobic really mean as far as the type of physical activity. Now, as you're watching this, I am going to ask two questions within the video that I'm going to have posted as discussion board questions, okay? And I'm not going to post the actual questions. I want you to pay attention. Basically, treat this as if you're sitting through class. Make sure that you take notes, you listen for the questions, and write them down when I ask them. So in looking at anaerobic training, you are essentially looking at two separate types of systems that work anaerobically. You have what's called the anaerobic alactic system, and you have the anaerobic lactic system. So the long-term adaptations that you have to your anaerobic training is going to be essentially based off of how you're utilizing those two systems. So unlike the aerobic system, which is just the aerobic system, the anaerobic training has these two different types. The alactic system tends to use exercises that are in much shorter duration, so we're talking less than 10 seconds. And they minimize fatigue during alactic training by taking longer rest intervals, so sometimes taking up to 5 to 7 minutes of rest. Whereas the anaerobic lactic system, this is a longer duration interval type anaerobic training that goes, the individual work bouts will go beyond 10 seconds, and the rest intervals are much shorter. Typically, you have rest intervals between 20 and 60 seconds, depending upon how long your work intervals are. So again, anaerobic training involves high-intensity intermittent bouts of exercise. So this is things like your weight training, your plyometric drills, your speed agility, and your interval conditioning that will specifically train the anaerobic systems, okay? And a lot of our athletes that we work with, they have to have a very efficient functioning anaerobic system in order to be able to produce power and force with their sprints, and more specifically in repeat sprint ability sports, to be able to repeat that over and over again. Now, there's adaptations here that go much beyond just the energy systems and some of the other effects of the exercise, so beyond the muscular level, and beyond looking at just the metabolic impact of this, there's adaptations along the neuromuscular chain depending upon depending on the type of activity and how it's organized. So we talk about activity in the brain centers going all the way down to the level of the individual muscle fibers to create adaptation. And some of these adaptations are some of the more important things we're looking at, particularly when we look at force production and power and things like that. This becomes very important. Looking at the neural adaptations, so if you look at this picture here, this entire picture kind of shows you all the different things that interact within the nervous system. So you have the higher brain centers here in the motor cortex. You have the descending corticospinal tracts, which are just basically tracts that go from the cortical regions in the brain down the spinal cord. You can see how they kind of show how they go through the rest of the spine. You have issues with the stretch reflex, which we'll talk about. You have the muscle fibers. Now, obviously, there we're looking at more hypertrophy benefits, so just more things to the connective tissue, not so much the nervous system, but things like the stretch reflex, changes that occur at the neuromuscular junction. So the neuromuscular junction is where the nerve kind of innervates the muscle. Now, one of the questions I have, so we talked about this in class, is that we have adaptations of our motor units. So what did we define a motor unit as? So that's going to be discussion question number 1. Okay, what is a motor unit? And we have central adaptations that occur. So basically, the central adaptations, again, the central nervous system consists of the brain and the spinal cord. So the motor cortex activity will increase as the level of force that gets developed during the exercise begins to increase. And it's going to increase even more when you're doing new or novel exercises. So there's going to be a lot of different neural changes that take place with this, and they're going to take place also along the descending corticospinal tract. And then you're going to start to see, and again, a lot of this will depend on what type of training, but for instance, maximal strength and power increases will come from anaerobic training, particularly training the alactic system, through increases in the agonist muscles. The agonist muscles are the muscles that do the work, and that will result from an increase in recruitment, rate of firing, synchronization of firing, so how well they synchronize fire, or a combination of factors. So what will happen is the motor units will get recruited. There will be an increase in recruitment. They'll fire faster. They'll fire at the same time. So there'll be some combination of those factors that will produce greater power and strength increases in individuals. Okay, so if we look here at the size principle, so what we have in the picture is looking at how much force production there is and what type of motor units. The motor units particularly referring to the two types of muscle fibers that we had talked about in the previous chapter. So that's going to be the second kind of discussion point that I want you to post in the discussion board is give me 3 characteristics of type 1 fibers and give me 3 characteristics of type 2 fibers. So give me 3 characteristics of each one of those. All right, so here we're looking at how these motor units get recruited. So as you look at this, as the force production increases, so this would be with heavy resistance training. So someone's doing squats or bench press, deadlift, whatever, any type of heavy resistance training, what'll happen is all the muscle fibers get recruited in a sequential order by their size. So the smaller ones will get recruited first, but since they can't handle the load, the type 2 fibers will kick in and they'll get recruited. Now, in advanced lifters, there is the belief that potentially the central nervous system could bypass this and have a greater tendency to recruit the type 2 fibers, okay? But typically in most individuals, what you're gonna see is just a recruitment of all the fibers, again, starting with the low threshold motor units, the type 1 muscle fibers, and then as the intensity of the set, and this is gonna happen pretty quick. So this is like you're doing a heavy set of 3, a heavy set of 5, you're gonna be doing in recruiting the higher threshold motor units that will produce more force. Okay, so looking at some more neural adaptations. Again, we're looking at neural adaptations throughout the nervous system. So now we're looking at it at the neuromuscular junction. So if you go back to looking at that picture, the neuromuscular junction is where the nerve and the skeletal muscle fibers kind of come together. And this is another potential source for neural adaptation as someone does anaerobic training. Now, it's a difficult structure to look at, but they have found through some animal studies that there have been changes. So some of the possible changes that include increasing the total area of the neuromuscular junction. So the overall area of the neuromuscular junction increased. There was a more dispersed, irregularly shaped synapses and greater total length. So we see overall there's greater area and more space kind of created by the neuromuscular junction, which is going to allow for, again, better recruitment of those fibers that are within that motor unit. And then increase end plate length and area, as well as greater dispersion of the acetylcholine receptors. So acetylcholine is the neurotransmitter that will transmit the information from the nerve to the muscle to create the response when called upon. And that will be another adaptation. So these are different things that do happen at the neuromuscular junction, again, increasing one's ability to recruit motor units. Okay, another type of neural adaptation that's going to occur is a neuromuscular reflex potentiation. So what this refers to is something called the myotatic reflex. The myotatic reflex involves the involuntary elastic properties of the muscle. So this is where muscle also has elastic properties. This reflex potentiation allows us to use that elastic property to increase force production without actually using extra energy, okay? And resistance-trained individuals tend to actually have a better reflex potentiation than people who are not resistance-trained. So anaerobic training may enhance the reflex response, and this can actually, again, further enhance the magnitude and rate of force development. So even in things such as jumping, like plyometrics, that's where this comes in, where the muscle and the connective tissue will actually act to help increase force production. Okay, so more neural adaptations that will occur, and then we look at anaerobic training and electromyography studies. So EMG is a way that researchers will actually use to test the neural activation of the skeletal muscle. This is where you'll use electrodes, either a needle or a fine wire, to kind of really pick up, or they'll use surface electrodes. And what they're actually just looking to do is pick up the activity of the muscle while doing different types of activities. So what you basically look at is an increase in EMG indicates greater neural activation, and they found that studies that have investigated this have shown that strength and power with this also increases up to 73%, because what you're showing is a greater activation and a greater recruitment of the muscle. Advancements in training have allowed for further gains. So as we're kind of seeing more and more different types of training, we're kind of learning some new things that we can utilize as a component of training to help increase this response. So dramatic increases in neural adaptations tend to take place very early in the training program. So we sort of did actually mention this earlier in the semester. We had talked about how, particularly in young athletes, they tend to get stronger before they get bigger. And some of that is because that the neural adaptations actually take place first. Then once you kind of get beyond, is that the training time frame increases, and they say it's usually greater than 10 weeks, muscle hypertrophy then starts to take place. So for the first 6 to 10 weeks, most of the adaptations are going to be more neural based and focus more on strength. Then as we look time down the road, we look at increasing hypertrophy and increasing the size of the connective tissue. Now, in particular, we look at neural adaptations taking place at 85% of a 1 rep max, or doing lifts or strength-based movements to elicit muscle power, which will utilize some different percentages depending on what you're doing, but the key percentage for just pure strength training is greater than 85% of a 1 repetition maximum. The key is with some athletes is to make sure that the programs adapt over time to accommodate as eventually the muscle hypertrophy plateaus start to take over time because of accommodation to the training load, that it's important that the individual will incorporate new variations into the plan of training. Okay, looking at some further stuff related to electromyography studies or EMG studies, the additional findings that we had is greater cross-education. So what they find is, exercising muscles in unilateral resistance training. So think of a unilateral exercise like a single leg squat, okay? So the belief with cross education is that when doing the unilateral resistance training, you actually get increased strength and neural activity in the contralateral muscle. So that's cross education. So that's actually an important thing, particularly when you look at athletes who are injured. If they have a limb that they can't do things on, they do get some carryover to strength. So if they do things using the healthy limb, the immobilized limb, or the limb that they can't use as well, will actually increase in strength. So that's an important thing to be thinking about, particularly for those of you that are looking to get into the more to the rehabilitation sciences like athletic training and physical therapy. There does tend to be in untrained individuals what's called a bilateral deficit. And essentially what this means is that in individuals when both limbs are now in contact, so now we're looking at both limbs being in contact with the ground, the force produced by them is lower than the sum of the forces when contracting unilaterally. So basically, if they measure the forces in somebody that has this bilateral deficit, what they find is that when they measure the force of the two legs and then they go and measure something unilaterally, if they add up the unilateral force production, it's actually greater than both limbs together. And again, that's something that you'll typically see in untrained individuals. So with longitudinal or long-term bilateral training, that bilateral deficit will eventually decrease, and eventually what you'll end up having is what's called bilateral facilitation, where you're getting an increase in the voluntary activation of the agonist muscle groups. You're also going to get changes in the muscle activity of the antagonist during agonist movement. So again, the agonist muscle is the muscle that produces movement. The antagonist is the muscle on the opposite side. And antagonist muscle groups also respond with strength training. So in most instances, co-contraction of the antagonist serves as a protective mechanism to increase joint stability and reduce injury. The problem with that is if you get too much opposition, it's going to limit your force production. So what essentially the body looks to do is adapt by using the antagonist only when it needs to, because then what you're doing is when you need co-contraction, you get it. Elsewhere and other things, when you want to have that timed a little better, you get a little better response. So you do want to have some activity in the antagonist muscles when you need that protective mechanism for certain movements, but what you don't want to have is it opposing it too much, and we think that there's changes in that activity that help improve force production. Okay, so now looking at the muscular adaptations and what goes on at the skeletal muscle, and what's going to go on at the skeletal muscle is basically going to be a combination of protein being synthesized and also utilizing kind of the metabolic environment to help have potent anabolic hormone response release as a result of the type of training that we're doing. So we're looking at adaptation in the skeletal muscle. We're looking at muscular growth, and you talk about muscular growth, hypertrophy. So hypertrophy is basically increasing the size of the muscle. Okay, so when we refer to hypertrophy, that's as opposed to atrophy, is when we refer to a decrease in the size of the muscle. So we're looking to do a couple different things with muscular adaptations, particularly as it involves hypertrophy. So hypertrophy is going to involve an increase in the synthesis of the contractile proteins, actin and myosin, within the myofibril. So if you're unfamiliar with what actin and myosin are and what the myofibril is, go back to that picture that we looked at, the anatomy of the muscle that we talked about in the earlier chapter. There's also going to be an increase in the number of myofibrils within a muscle, and the new myofilaments result in an increase in diameter of the muscle. So again, there's going to be important things that have to take place for muscle hypertrophy to occur. We look at mechanical deformation of the muscle, which is going to help to stimulate protein synthesis and create this response. And there's other mechanical factors that are involved as well. So we have to have the lifting of relatively heavy loads. We have to include eccentric muscle actions where the muscle is lengthening and utilizing that type of contraction to support the strength training that we're going to be doing. And we also have to look at metabolic factors. So in low to moderate intensity or moderately high intensity training with high volumes and short rest intervals, where now you get some metabolic factors that play a role. And that's usually what you see in bodybuilding. Okay, so bodybuilding, you will typically have low to moderate intensity and moderate and short rest intervals to help create that hypertrophy response. That's as opposed to looking at some lifting heavier loads that, say for instance that an athlete, an Olympic weightlifter or a power lifter would do. Now, hyperplasia is something else. So also proposes a mechanism for increasing muscle size, and it's been kind of debated as to how much this plays a role as hyperplasia. So hyperplasia involves an increase in the number of muscle fibers via splitting. So basically what they're saying is when you do high intensity resistance training, the muscle fibers will split and create more muscle fibers. Now, this has been kind of controversial in humans. They're not quite sure if this does happen. And while we can't completely rule it out, it does not appear to be necessarily a major strategy for muscle tissue adaptation and resistance training. It may only be a small amount that actually contributes to an increase in size. So primarily what we look at is a change in the size of the fibers. We don't necessarily have the splitting and creation of new fibers. There are some programs that proclaim to do it. It just hasn't been totally proven yet. And they also do think it may occur in response to muscles possibly reaching their theoretical upper limit, and that'll happen in individuals who take anabolic steroids. So if someone takes anabolic steroids whose muscles have reached their upper limit, there may be a hyperplasia response to their training. Adaptation, so we're still looking at that now. So we have fiber size changes. So resistance training results in an increase in both type 1 and 2 muscle fibers. So it's important to look at, since they could both be recruited, we will have an increase in the size of both of them. Type 2 fibers have greater increases in size than type 1. So type 2 fibers have a much greater chance to produce hypertrophy. They tend to get bigger faster as a hypertrophic response to training. Typically, type 2 fibers do manifest greater increases in size than type 1 fibers. And so the magnitude of hypertrophy is not uniform between the two fiber types. And they actually think that it's argued that the ultimate potential for hypertrophy resides in an athlete having a high proportion of type 2 fibers. So athletes who genetically have large proportion of type 2 fibers tend to have greater potential for increasing muscle mass and also being, tending to be more powerful, more explosive than athletes who have predominantly type 1 muscle fibers. Now we also have potentially some fiber type transitions that could occur, and we have a picture doing this. So we do have a continuum of fiber types. So we primarily talked about type 1, type 2A, and type 2B in the previous chapter, but we have all different types of muscle fibers. So the pattern of neural stimulation kind of dictates how these muscle fiber type adaptations will occur with anaerobic training. So again, they're positioned on a continuum from the most oxidative to the least oxidative type. And so when we look at this picture, the continuum is as follows. We have type 1, type 1C, type 2C, type 2AC, type 2A, type 2AX, and type 2X. I had said type 2B. That sometimes people use terminology B to replace X, but they both basically mean the same thing. So again, although the proportions of these are kind of genetically determined, changes can occur within the subtypes, okay? So we look at the subtypes of type 1 and type 2, we can kind of create some changes and some transitions between them based upon the type of anaerobic training. So basically what that's saying is that the type 1 and type 2 fibers stay put as they are. You're not going to change from type 1 to type 2. More than likely, what's going to happen is you're going to change in the subtypes, okay? So the type 2 fibers, within your type 2 fibers, depending on the type of training you're going to do, you're going to be changing up the expression of those different types of motor units. So what we'll do now is just look at some of the ways that the fiber types could transition. In your book. So as we see, what we're primarily looking at is changes within the subtype. So we don't think there's crossover between type 1 and type 2. It appears very less likely that could happen, although there's the belief that we should maybe study and see if individuals with a high percentage of type 1 fibers, if they follow a higher intensity resistance training program, if they do change those types. We haven't seen those changes quite yet. So we do see transformations from type 2X to type 2AX to type 2A, and that could be seen, and then there's a small percentage of change of type 2AC and type 2C. So the exercise activities that recruit motor units with type 2X muscle fibers tend to initiate a shift towards the type 2A fibers. So they actually found this looking at a resistance training protocol where they use a 6 to 12 repetition max loads with 2 minutes rest. They reported a significant decrease in type 2X percentage in women after just a couple weeks of training, and in men after 4 weeks of training. So basically what they said is about an 8-week training program with 6 to 12 repetition max loads, the type 2X fibers have actually decreased to a smaller percentage of the total muscle fibers. So that they found that the analysis of this in the early phases of training, that type 2X fibers are replaced with type 2A fibers. And then they found that detraining had the opposite effect. In other words, when they stopped training, the type 2X fibers started to come back, and we had a reduction in the type 2A fibers. So It is possible to change within subtypes of activity. However, what we said was you're probably not going to have a change from type 2 to type 1 when you're looking at those extremes with the muscle fiber transitions. Okay, so this is the last slide of the video. I'm not going to talk about anything else. We'll pick up with this on Monday. So if you have to kind of go through, look at your notes again, or you have any questions, don't hesitate to ask, and I'll help you out with any questions that you may have. Remember to post those discussion questions that I had in the discussion board. That will be due on Monday, because I'm expecting you to have done this, and it's going to be just a short post in the discussion board.